Let's discuss question number 44 from test 5. This is from engineering mechanics. The friction, the coefficient of static friction within block, and the table is μs. Okay, so you have a block, you have a table, and you have a kind of a pulley where one mass is just hanging and the other is connected to a block which is in contact with the table. Okay, so this is 2 kg block and this is small mass m. So what is asked is, if I just increase this m value, obviously there will be a point where this 2 kg, so let's say m is 0. Okay, let's say small m is 0, start from 0, then there will not be any horizontal pull on this 2 kg. As I increase mass m, the tension will build up in the wire and that will act as the horizontal pull on the 2 kg, but then you have a friction which will resist. So there will be a point, because the table and the contact, the interface between the 2 kg block and the table can supply only maximum static friction. Beyond that, if you apply more force which balances this maximum static friction available, then it will move right. Okay, that is the point where it is asked, what should be the maximum value of m so the blocks do not move, or the other way of saying is, what is the minimum value of m such that the blocks start to move. That's the same problem. So if I take this 2 kg, this is the tension and you have the friction, let's say F, and you have the normal reaction N and the weight, the 2 kg, so 2 into G. So now maximum value of m such that the blocks do not move means maximum. So if I add just a small 0.1 gram to that, it will start moving. So at this point it is on the verge of sliding forward, right? The root 2 kg, because just add 0.1 gram to small m, at this point it will start moving. So it's on the verge of sliding forward, and the friction is maximum static friction which a surface can provide, because if it is not maximum static friction, you can still add 0.1 gram or 0.2 gram and it will be at rest. But we are not looking at that. We are looking at a point when it's just about to slide. That means it has overcome the static friction, it is in the kinetic zone. So maximum static friction available, so F is F max. So when F is F max, then only it is μs into n. Okay, so now if you just do the force balance, so T minus μs n, it's on the verge of sliding forward, but it is in static equilibrium, right? Just in static equilibrium, because it's not moving. Okay, so this is 0, and if you just do the vertical force balance, because vertically the block will not separate, so n is 2g, and if you just substitute here, so T is μs into 2g. Okay, now this tension, if you come from this block for small m, so if the force that is only acting on this is mg on the small hanging block and the tension. So as it is in equilibrium, so T has to be mg. So if I combine these two, mg has to be μs into 2g, g's gets cancelled, m is 2 into μs, and μs is, the value of μs is 0.2, so you have 0.4 has to be the maximum mass that can keep the system in equilibrium without any moving. But if you add small anything to it, it will start moving. So 0.4 kg is what is the maximum value, should not move. So the answer for this is B. Thank you.